Hi everyone. Now, see the problem here. Compute A and B such that the surfaces ax square minus by z equal to a plus 2x and 4x square y plus z cube equal to 4 cut orthogonally at the point 1 comma minus 1 comma 2. So problem is there are two surfaces are given with unknown values a and b at the point 1 comma minus 1 comma 2. The important thing here is two surfaces cut orthogonal here. So we are going to apply orthogonal condition here. So the orthogonal condition is del pi 1 dot del pi 2 equal to 0. Okay, right? So first take the first equation. So this is pi 1. Uh, Pi 1 equal to ax square minus byz minus a plus 2x. This is not equal here, it is minus. Right now, first to find del pi 1, okay? That means differentiate this with respect to x. What happened? 2ax, right? Then differentiating this become a plus 2. So minus is there. Minus a plus 2, that means minus a minus 2. Then differentiate with respect to y, become minus bz. Differentiate with respect to z, become all terms are 0 except the center term, become minus by. Okay, now simplify this. At the, we get this one. That means at the point 1 comma minus 1 comma 2, put x equal to 1 here, y equal to minus 1, z equal to 2 here. We get this vector. Okay, after simplification, 2a minus a become a here, right? A minus 2 I vector minus 2 bj vector plus bk vector. Okay, what about next surface? Pi 2 is 4x square y plus z cube minus 4. Okay, now similarly find del pi 2 for this curve also. What is del pi 2? We differentiate this with respect to x, 8xy. With respect to y means 4x square, these terms become 0. Differentiate with respect to z means 3z square. Right? For this, differentiate with respect to x. For this, differentiate with respect to y. For this, differentiate with respect to z. Now substitute the point here. Okay, we get minus 8i vector plus 4j vector plus 12j vector. After substituting the point x equal to 1, y equal to minus 1, z equal to 2. Since the two surfaces are orthogonal, so given thing the two are orthogonal. That means both gradients are dot product must be equal to 0. That is del pi 1 dot del pi 2 equal to 0. What is del pi 1? This is del pi 1. Okay, put here. What is del pi 2? This is del pi 2. This is del pi 2. Put here. Now take dot product. That means multiply corresponding components. So here we have a minus 2. Here we have minus 8. Okay, minus 8 a minus 2. Similarly, here we have minus 2b. Here we have 4 minus 8. Here we have b. Here we have 12. Now multiplying this become minus 8a minus 8a minus 16. I mean plus 16 plus 8b plus 12 equal to 0. Okay, simplify this expression. That means minus 8a minus 16. This become plus 4b. Okay. That means dividing this equation by minus 4. If we divide this equation by minus 4, we get simple equation, right? So this is equation number 2, right? So we get one equation. To get another equation, since the point 1 comma minus 1 comma 2 lies on the surface. What is the surface here? This surface. Put x equal to 1, y equal to minus 1, z equal to 1 in this surface, right? We put like this, we get a1 square minus b of minus 1 2 equal to a plus 2. After simplification, we easily find b equal to 1. If we put b equal to 1 in this equation, we find a equal to 5 by 2. So this is a very important question. Okay, next another important topic is divergence and call very important topic. Okay, divergence. Suppose f vector is f1 I vector plus f2 j vector plus f3 k vector and continuously differentiable vector point function, then divergence or del dot f, either it is divergence or another mathematical symbol is del dot f, is defined like this. Del is simply operator, f is f1 I vector, f is f1 I vector, f2 j vector, f3 k vector. If we take dot product means I dot I become 1. That means dou by dou f1 by x. Dou by dou f2 by y. Dou f3 by dou z. Right? Very simple this one. Take only components of x, I, j. Leave the vectors. Okay. Dou by dou x into f1. Okay. Dou by dou y f2. Dou by dou z f3. Okay. We get this one. So there is no vector here. There is no I vector, j vector, k vector here. Therefore, del dot f is always scalar. Next one is curl. Same thing. F vector is f1 I vector, f2 j vector, f3 k vector. Then curl of f vector or del cross f vector is defined like this. Del vector is simply this. F vector is given vector f1 I vector, f2 j vector, f3 k vector. Then it is very easy. First to put a determinant. Okay, determinant symbol here. First write the components I vector, j vector, k vector. First write the operators dou by dou x, dou by dou y, dou by dou x, because operators are first here. Okay, then put the values of f1, f2, f3 here. Then expand the determinant as usual. Okay, so it's a very important concept in vector calculus, in vector differentiation, divergence and curl. Del dot f vector and del cross f vector. Okay, no problem. Find divergence of the vector field A vector as given at the point 2, minus 1, 1. So the divergence of vector field means simply del dot f. Divergence means always del dot. Del dot given vector A vector. Okay. How to find del dot A vector? So first differentiate this component with respect to x. Differentiating this becomes y is it because x becomes 1. Second component with respect to y. Right? Differentiating this with respect to y, we get 2x z. Okay. Last component with respect to z. What happened? If we differentiate this with respect to z, we get simply y square. So 2x z. Differentiating z square means 2x z. Okay. Right. Now substitute the point here 2, minus 1, 1. We put the point here. After simplification, we get this result. Okay. If we differentiate this with respect to x z to 2x z, if we differentiate this with respect to z, minus x. That's correct. Now next problem. Find the curl of the vector. So first to put f vector here. Right. This is f vector. Curl of f vector is del cross f vector. Del cross f vector is simply write the component vectors in the first row. Then put the differential operator. In the last column, vectors xy, yz, zx. Okay, this is very easy. Right? If you expand through this, what happened? Dou by, leave first column, first row. Dou by dou y into zx. That means differentiate this with respect to y. It becomes 0. So 0 here, we don't here. Then minus, multiply these two. That means differentiate this with respect to z. This is function, this is operator. So here we have z here. So differentiate this with respect to z become y. So minus 1. Similarly, minus j into, leave the center column and first row. Now multiply these two. That means differentiate this with respect to x. So we have z here. Differentiate this with respect to y becomes 0. So minus z. Similarly, this column. Okay. Next problem. Same thing. Problem. If x square I vector minus y square j vector minus z square k vector, then find del dot f vector and del cross f vector. So in one problem, we are going to find del dot f vector and del cross f vector. What is f vector here? X square I vector. Actually, this is plus y square. Minus n is changed here. Plus y square. This is plus z square k vector. Del dot f vector is differentiate first component with respect to x. Okay. Right. Second component with respect to y square. Third component with respect to z. That is 2x plus 2y plus 2z. After simplification, 2 into x plus y plus z. Del cross f vector means put I, j, k like this. Then differential operator. Then write the components x square, y square, z square. See here. Leave the first row, first column. Multiplying this, differentiate with respect to y means simply 0. This is actually 0. Dou of dou y z square means 0. Same thing here, minus same thing here. See here, dou by dou z square means there is no y term. So 0, 0, 0, 0. Everything is 0. Becomes 0 here. Okay. Next problem. If f vector equal to x cube I vector plus y cube j vector plus z cube k vector, then find divergence of curl f vector. What is curl f vector? Del cross f vector. Write ijk here, put the derivatives here, write the components here, expand the determinant, we get del cross f vector equal to 0. Divergence of del cross f vector means del dot del cross f vector. Del cross f is 0 here, del dot 0 is 0 here, right? Now solenoidal and rotational. Suppose if a vector dot del dot a vector equal to 0, del dot a vector means divergence. If divergence is 0, then a vector is said to be solenoidal. If del cross a vector equal to 0, or what is this? Curl a vector is 0, then it is called irrotational. Okay. Now see here, prove that the vector f vector equal to f vector equal to zi vector plus xj vector plus yk vector is solenoidal. Very simple, just to find del dot f. Okay. So this f vector, to prove solenoidal, we should prove del dot f vector equal to 0. That means differentiate first component with respect to x. There is no x term, so 0. Differentiate this with respect to y. There is no y term, 0. Differentiate this with respect to z. There is no z term, so 0. Therefore, f is solenoidal. Next, if v vector equal to x plus 3y, I vector plus y minus 2z j vector plus x plus lambda z k vector is solenoidal, then find the value of lambda. So given that it is solenoidal, that means del dot v vector equal to 0. So del dot v vector means first differentiate this with respect to x become 1. With respect to y becomes again 1. With respect to z becomes lambda. What is here? 0. So what is the value of lambda? Lambda equal to 2, right?